Okay, forget everything you think you know about prehistoric flight. Seriously, when most people picture pterosaurs, they imagine these kind of clumsy, leathery reptiles desperately flapping around, right? Practically falling out of the sky. Well, what if I told you that modern math and aerodynamics have completely thrown that old story out the window? Welcome to today's Explainer, where we're going to dive into the hard data and the actual fossil evidence to show you that pterosaurs were, without a doubt, the most perfectly engineered biological flying machines to ever exist on Earth. I mean, their evolutionary journey is just an absolute masterclass in dominating the skies. Let's get into it.
Let's immediately shift our perspective on scale here because it's wild. I want you to picture an animal, specifically the Quetzalcoatlus northropy. Imagine an animal standing exactly as tall as a modern giraffe, but then it unfolds its wings and it has the 10.5-meter wingspan of an F-16 fighter jet. Yes, you heard that right. We are talking about a living, breathing creature that massive, capable of taking off directly from the ground. Honestly, it's almost impossible to wrap your head around until you see the specs laid out side by side like this. And just to show you how ridiculously successful this biological engineering was, 162 million years. That is the number. That is how long these absolute aviation marvels completely dominated the skies. Throughout the entire Mesozoic era, while the dinosaurs were ruling the ground, pterosaurs had absolute aerial supremacy. To put that into perspective for us, human aviation is barely over a single century old. These guys held the crown for 162 million years, adapting into hundreds of different species across all sorts of climates, very much like modern birds do today. So to figure out how they pulled this off, here is our flight plan for this explainer. We are going to cover the rulers of the skies, social and biological secrets, the takeoff rebus, the engineering of the wings, and finally, how they were perfect flying machines. All right, starting off with part 1. The rulers of the skies. Let's talk about those 162 million years. You know, for the longest time, we were completely in the dark about how these animals actually functioned. Our understanding has gone from total, utter confusion to just absolute awe. Check out this timeline. Back in 1784, an Italian scientist named Collini looked at the very first discovered pterosaur bone, and the anatomy was so bizarre to him that he literally identified it as a marine animal. I mean, it took decades for anyone to even realize these things flew. The issue was always that their hollow bones degrade so fast, making fossils incredibly rare. But jump ahead to 2001, and we see this massive wave of complex discoveries out of China. And the real biological treasure trove? That hit in 2017 when researchers found 200 intact pterosaur eggs just sitting in the Gobi Desert, complete with preserved embryos inside. It was a total game changer. Which brings us right to part 2, social and biological secrets. That incredible Gobi Desert find leads us perfectly into what is basically paleontology's modern El Dorado in regions like China and Burma. What they found there completely rewrote the book on their reproduction and social structure. Take the Darwinopterus species, for example. They found a confirmed female fossil, confirmed because she actually had an unlaid egg still inside her oviduct. And get this, she completely lacked a head crest. But the males, highly ornate, with these giant elaborate crests. This brilliantly proves that those crazy crests were evolutionary male ornaments used for social display, exactly like the spectacular, flashy feathers we see on male birds today.
Okay, moving to part 3, the takeoff rebus. How on earth did they defy gravity?
So math models from the University of California have really helped us completely erase the old, kind of silly ideas about how these giants got airborne. Some scientists used to think they dragged themselves on their bellies, or did this weird zombie walk on their back legs using their wings as crutches. Some literally claimed they couldn't take off from the ground at all and had to hang upside down from cliffs like giant leathery bats. Well, the UC scientists ran the aeronautical equations and proved that the cliff-hanging theory has zero scientific foundation. No way. The math actually showed that for the really massive pterosaurs, a two-legged takeoff would have literally shattered their huge femurs under the stress. So what did they do? They used a ridiculously powerful, weight-distributing four-legged biological launch to catapult themselves into the sky. It started evolutionarily with little proto-jumps, moved to gliding, and eventually culminated in this incredibly explosive four-legged launch. Let's look closer at that equipment in part 4, engineering of the wings, the true anatomy of flight. Based on some exceptionally preserved fossils found in Germany and Brazil, we now know their wings were bordered by an extremely elongated fourth finger. Just imagine your ring finger stretching all the way out to support a literal airplane wing. But the membrane itself wasn't just a simple flap of skin. It actually had 3 distinct, highly engineered layers. The top layer had these fan fibers for structurally folding the wing away. The inner layer was packed with actual muscles and connective tissue. And that bottom layer, it was highly vascularized, meaning it was constantly pumping with blood. Because the membrane attached all the way down to their legs, by actively contracting those internal muscles and moving their ankles in and out, they were literally shape-shifting their wings mid-flight. They could actively adapt to any aerodynamic phase on the fly.
And if you want to talk about the sheer depths of their engineering, we have to talk about the pterosaur bone. Paleontologists found this highly specialized wrist bone that is completely unique to pterosaurs. And you know what it did? It functioned exactly, and I mean exactly, like the aerodynamic flaps you see on the back of the wings of a commercial airliner. By just adjusting the angle of this one single bone, a pterosaur could dramatically increase its lift at low speeds. Meaning they weren't just passively gliding around up there, they were actively managing their low-speed performance. This gave them a level of maneuverability and control that the ancient skies had literally never seen before. A true game-changer.
But here's the thing. Controlling an actively changing, living wing requires some serious biological computing power, and that brings us to their skulls. Now, you might be wondering, how does a flying creature support the weight of those massive, elaborate crests we talked about earlier? Well, the secret is their skulls were incredibly hollow and lightweight. Actually, the outer layer measured less than a single millimeter thick. It's like eggshell fin. But inside that feather-light skull housed these absolutely massive brain lobes. These enlarged brain regions acted as literal onboard flight computers, specifically engineered to process the enormous amounts of complex telemetry and sensory data constantly feeding back from that muscular, blood-pumping wing membrane. Which leads us to our final section, Part 5, Perfect Flying Machines. So how do they stack up against modern flyers? When we compare their engineering specs to modern birds, pterosaurs actually took hollow bones to the extreme. They were even more hollowed out, lightweight, and fragile than bird bones. And when it comes to muscle force, studies show pterosaurs employed a much, much higher percentage of their overall body weight to power their flight compared to modern birds. But what about their actual efficiency in the air? Well, those UC scientists found that certain long-distance species like the Pterosaurus achieved a hyper-aerial gliding efficiency that directly matches the modern albatross. Think about that. They were perfectly evolutionarily engineered to just effortlessly ride the massive thermal updrafts over the Mesozoic ocean. When you really step back and look at the math, the anatomy, and the fossil evidence, it is undeniably clear. Pterosaurs were absolutely not prehistoric mistakes or evolutionary dead ends. They were the undisputed apex of aeronautical engineering for 162 million years. Which leaves us with a final, kind of provocative thought for our explainer today. If applying modern math and aerodynamics completely transformed our view of pterosaurs, taking them from clumsy, falling reptiles to perfect flying machines, what other mechanical marvels are just hiding in the fragile fossil record, waiting for our science to catch up? Thank you so much for exploring the skies with me today. Keep questioning, keep learning, and I'll see you next time.